Most of the time we use trigonometry in order to solve triangles that are right. But there are times when we might have a general triangle that doesn't necessarily have a right angle. We can actually use the law of cosines and the law of sines. We're going to be looking at just the law of cosines in this video for you to kind of get a better understanding of how to find side lengths and angle measures based on the law of cosines. So what is the law of cosines? The law of cosines, again, is based on just a general triangle in which we have side lengths A, B, and C. They'll be denoted with lowercase letters. Angle A, notice these are opposite of the triangle. Angle B, and angle C. So angles are denoted with capital letters, lowercase letters are your side lengths. So with this, A squared equals B squared plus C squared minus 2BC times the cosine of A. So you can switch this around depending on the side length you are trying to find or the angle measure that you are trying to find. If you want to switch the B squared and the A's, if you want to switch the B's and the A's, just make sure that you switch all of the components around. Okay. So let's look at an actual example here. So let's say that I have a triangle that has all side lengths. I'm going to find the measure of angle A and the measure of angle B in order to find my third angle measure. Now, just something to note, when you're using the law of cosines, you can only use the law of cosines together. You can't use the law of cosines for one angle and the law of sines for another angle. It doesn't quite work that way. So with that being said, we're just going to use our law of cosines in order to find the measure of angle A. So if I'm looking at this, 29 is my lowercase a, 48 is my lowercase b, and 31 is my lowercase c. That's the first thing I always do is I always go through and label everything to make sure I know what's what. Then all I have to do is just plug it right into my formula. So I've got 29 squared equals 48 squared plus 31 squared minus 2 times 48 times 31 cosine of A. So from here, I go through and I actually simplify some of my components here. So I've got 841. Now when I combine these components, this number here is associated times the cosine. So I cannot take 48 squared plus 31 squared and then minus that 2 times 48 and 31. I have to have that component together because they are multiplying. If I was in fact adding or subtracting between that 2, 48, and 31, then I could actually subtract them, but I can't. Okay, this is what a lot of people struggle with. So I combined these two right here to give me 3,265 minus 2,976 cosine A. So now I'm just going to keep going here. I've got to subtract that 3,265. I get negative 2,424 equals negative 2,976 cosine A. Because that negative is being multiplied by that cosine, I'm going to go ahead and divide. You will get a long decimal, and that is okay. It'll be 0.8145 equals cosine of A. So when I do this, remember when I'm trying to find an angle measure, I have to use the inverse of my cosine. So it's going to be cosine -1 of that 0.8145. So my angle measure, make sure I'm in the correct mode of degrees here. That angle measure is going to be approximately 35.5 degrees. So I found one angle measure. I'm going to have to go through this whole process again in order to find the measure of angle B. And then I can go through and just take 180 and subtract off those two angles because we know that an angle, the angles in a triangle add up to 180. So I'm just going to go ahead. All of this should be written down by now for most of you. Just restart this process. So what I'm going to do is I'm actually just going to switch all the a's and b's around. So now I'm going to use b squared equals a squared plus c squared minus 2ac cosine of b. Okay, so I'm just using those values. So 48 squared equals 29 squared plus 31 squared minus 2 times 29 times 31 cosine of b. So I'm going to go ahead and simplify. 2,304 equals 1,802 minus 1,798 cosine B. I'll subtract off that 1,802 to give me 502 equals negative 1,798 cosine B. Divide by that 1,798. And now I take the inverse. In case you were wondering, when I type this in, personally what I do is I just take the inverse cosine of my answer when I divide it. So if you take the inverse cosine of that 0.2792, you might get a little bit different answer than what I am, and that's just because I'm using the inverse cosine of that true decimal. So I'm getting about 106.2. Which I can mark. And now that I know that, I know a triangle adds up to 180, so I can find the measure of angle C. And angle C is going to equal 38.3. And now I've found all of my angle measures within my triangle. You can also find side lengths using this. It's just my example didn't. And because I'm running close on time, I'm not going to show you an example, but this is how you use your law of cosines. This right here is how you can interchange between the formula. You just switch your a's and b's around, or your a's and c's, whatever values you want to switch.